Okay, thank you, Stephen. It's David here, and just like to welcome everybody online. Appreciate you joining our webinar today. Hope you find it informative and interesting. So electronic design, as you may know, is a highly complex task. It typically starts with logical design to implement the required functionality. Then the layout needs to be generated, and for this, sophisticated auto routing is typically applied. But finally, the layout needs to be simulated to verify that the design actually works. A typical PCB layout may have many layers, thousands of nets, and the complexity is only increasing as data speeds get faster due to growing bandwidth requirements, and power densities are constantly increasing. It's really a true multi-physics problem. Electrical, thermal, and mechanical aspects are all very important, and balancing all of these design requirements is certainly a big challenge. We look inside the PCB, we can see a huge array of vias. These add further complexity to the design. One can imagine, as signals pass from one layer to another through the vias, this can cause issues with signal integrity and also electromagnetic compatibility. So it's very critical to capture the design issues before fabricating the PCB, obviously to avoid significant costs and also, maybe more importantly, reduce the time to market. So, big question is always, will the PCB actually work? I'm going to start by talking about the electrical aspects. My colleague Wiran will discuss thermal and mechanical aspects later on. So on the electrical side, key issues are power integrity, signal integrity, and electromagnetic compatibility. For example, will the IC devices receive stable power supply? Will the signals arrive without too much distortion? Will there be electromagnetic interference between different parts of the PCB? Will it radiate electromagnetic fields too much? Will the PCB be susceptible to external fields when it's operating in its environment?